Assalamualaikum warahmatullahi wabarakatuh and salam sejahtera. I'm Muhammad Arif Hakimi by Rosmi. Want to present to you about the my final year project FIP1. That title is the Stanchion redesign for Kuala Lumpur Additional Vehicle KLAV 37 project based on SolidWorks simulation. Okay. The content that I will discuss to you is the introduction, literature review, methodology, result, and conclusion. Okay, firstly, I want to discuss to you about the introduction for this research. Okay, for the research background, the Kuala Lumpur Additional Vehicle 27, KLAV 27 project is an ongoing project under the Alstom-Hartasuma Consortium, ASC, as a main contractor to the to supply 27 new light rapid transit LRT trainset for the Kelana Jaya Line. So in this LRT train, there are station that equipped at the middle of the passenger compartment. So the SSC need to redesign the station for Class 37 fleet due to certain problem. This research will redesign the new station by considering the safety of the passenger and follow the standard requirement that provided by the OEM. The problem statement for this research is there are stations located in the middle of the passenger compartment. Uh, Based on the LRT accident that happened at 24 May 2021, the station is one of the hazard inside the train set that could passenger to injured during the collision. So based on this collision, the Prasarana Malaysia Berhad request ASC to justify the existing station design um, and removing that existing station and installing the new station for the KLAV 37 fleet. So this study is significant because this ratio will solve the problem of the existing station in Class 27 LRT fleet and reduce the hazard and the risk to the passenger. For the objective for this research is one is to identify the design specification and safety of the existing station. Second is to determine the impact of the existing station during the collision. And lastly is to formulate a new design of the station to reduce the impact of the collision on passenger. The scope of this research, this research is more focused on the Kuala Lumpur Additional Vehicle Class 27 fleet. The study will study on the passenger behavior when using the existing station. Second is identify the problem and hazard of the existing station. Analyze suitable station inside the LRT for the passenger safety, which can reduce injured during an emergency situation. And this study will apply, define, measure, analysis, improve, and control DMAIC for the problem solving tool and SolidWork for the design, analysis, and simulate the new station. Okay, I will discuss to you the literature review for this study. Okay, Kuala Lumpur Additional Vehicle KLAV 37 project. The Alstom-Hartasuma Consortium ASC got the contract RM 1.72 billion for supply 30 train set of 4 coach Bombardier Innovia Metro 300 trains for the Kelana Jaya Line. In this project, there are two companies that involving in this project, which is Alstom and the Hartasuma Sdn Berhad SSB. So the Alstom is responsible for the final assembly of the interior of the train body, and the system of the LRT train, where the Hartasuma Sdn Berhad is responsible for the bogie final assembly process and maintaining the facilities of the KLAV 37 project. So in this picture, in this slide is the picture of the Bombardier Innovia Metro train for the Kelana Jaya Line. So this train have several of improvement feature in term of their braking system, their passenger door, train management, auxiliary power supply system, and the additional of the digital route map display compared to the KLAV 14 fleet. So the KLAV 37 fleet will replace some of the two-car LRT transit, which is from the 414 series fleet that has operated since 1998, and the rapid rail neighborhood is in the process of receiving 19 new four-car train set for the Kelana Jaya Line in 2022. In 2021, the first two of the 27 new train set under the KLAV 37 project for the Kelana Jaya Line, LRT line, started operating. This is the chronology of the Kelana Jaya LRT train collision. This collision is happened when the NMT train TR14 was southbound toward to the Lembah Subang Depot installed near at Kampung Baru. This TR40 train is installed due to the automatic train operator ATO for TR14 is cannot be used, and the Operation Control Center OCC locate the TR14 and ask the driver to drive the train manually. At the same time, the TR81 is carrying passenger operating under the ATO, waiting at the KLCC station and toward southbound. After that, the TR81 depart from the KLCC toward to Kampung Baru after receiving the information that TR14 had already left Kampung Baru. Due to the certain problem at the both of the Heisler and the OCC train controller, they had ignored the crucial step while manually resetting both VOBC that caused the TR14 toward northbound. So because of this event, the TR40 and TR81 collide between KLCC and Kampung Baru station. So this is the impact of the collision during the LRT collision. Total passenger in TR81 is 230 passengers, which is under light operating situation based on this table in this slide. There are some passenger that are standing and seated under the light operation situation. The impact of this collision that more than 210 individual were injured, with 47 of them is suffer critical injuries, and both passenger that seated and standing were hurt as a result of the incident, who was injected and falling to the ground. So the stanchion and handrail design in Kelana Jaya Line. The interior of the KLAV 37 fleet shall be equipped with the sufficient horizontal and vertical stanchion. There are three vertical triple stanchion that located along the center line of each car. One aligned with the center of each door opening. A vertical stanchion shell to be incorporated into each windscreen assembly. The stanchion and handrail shall be made from brushed stainless steel tubing. The vertical stanchion will withstand a horizontal load of 1014 Newton in any direction. The stanchion and handrail shall be securely held at each end in fitteds. So this is the picture of the stanchion. inside the Kelana Jaya Line LRT fleet. The impact of a train collision risk on passenger. This figure show the how the passenger being injured during the train collision. Um, there are two type of the impact, which is primary and secondary impact. For this study, we will focus on the secondary impact because this impact is more serious than the primary impact. The secondary impact is caused by the direction force when the moving passenger collide with the interior car component or other passenger. The injury is happen when the primary and secondary impact acceleration surplus the human tolerant limit. The secondary impact is main focus of the study because the secondary impact can cause serious injuries and fatal injuries rather than the primary impact. This research also will be study the injuries in automotive field as a reference to know the secondary impact of the train collision on the passenger on board the train. According to the study that conducted at Japan's, the secondary impact in automotive field, 122 occupant at the steering wheel, 64 occupant at the front windshield, and 144 occupant at the instrument panel. So the head was the most seriously injured. It is assumed that the body was flung forward for the seat during the impact. In the railway field, the secondary collision occurred and immediately result in injuries due to interior equipment such as the seat, the stanchion, the handrail. So the standing passenger have a greater risk of the injuries due to the degree of freedom. Product redesign. This research is more focused to the redesign process of the existing station on board the LRT Kelana Jaya Line. So the factor of the redesign process is first improving the quality of an existing product. Second is to refresh the product appearance for customer who appreciate design change. Third is design flaws or issue are discovered during the product life cycle. So the product we will improve to more better to the customer. Uh, the other factor is to propose new need or specification. And lastly, the factor of redesign process is to emerge the new material or technique. There are two types of the redesign process, which is parametric redesign and structure redesign. For the parametric redesign, the structure of the design is fixed, but the change is the variable of that product is changed. For the structure redesign, the new structure would be clearly different from the structure in the old design. So the structure of the old design will be changed to the new product. Okay. So we move to the methodology. I will discuss about the methodology that I have used for this research. First method that I have used for this research is DMAIC implementation. What is a DMAIC? DMAIC is define, measure, analysis, improve, and control. So this DMAIC is a tool that I use for problem solving tool. So in define a step, we will focus on defining the objective of the project, scope of project, expected result, and the roles of the team. Uh, that's the next step is measure. that will be focused on the important element of the ongoing process, gather pertinent information and determine the process capability. Next step is the analysis. We will verifying cause and effect link and ensure all the relevant element have been taken into account while determining the relationship. The next step is improve the more focus on the data analysis and optimize the process by using the several technique. And the last step is the control. We will implement control strategy such as product board, visual workspace, statistical process control, and ongoing process monitoring. But for this study, we just go to the improve step because we just to propose the new design of the station. So this is the Gantt chart for the my final year project one. This Gantt chart show the all activity that I have done for final year project one. This is the flowchart for the final year project one. So the activity started from the formulation of the problem statement, objective and scope and outcome. After that, we do the literature review. After that, we study on the characteristic and structure of the existing extension. Next, we conducted the survey to design the new extension. After that is extension redesign process. After that, we do the analysis and simulation of the new extension by using the SolidWorks simulation. If the simulation is success, we go forward to the documentation. If the simulation is fail, we revise the extension design and do redesign process again. Um, After documentation, the research is done. For the data collection, first method that I have for data collection is reverse engineering. It is the sign of taking an existing physical model and reproducing its surface geometry in a three-dimensional data file on a computer aided CAD system. Instead, with the finished product and work backward to recreate the engineering concept by analyzing the system design and the interdependence of its component. The second method for the data collection is data collection of passenger behavior. This study will carry out a survey to collect the data on the number of the passenger that use the station on board the LRT train. The data on the number of passenger that using the station in each LRT will be collected to obtain the average value. Uh, the survey also identify the body posture of passenger when using the station. The literature review method is using for the data collection. The source of the literature review for this research is online newspaper, conference paper, review journal, and internet source from the Hartasuma Sdn Berhad and from Alstom. This is the design process in SolidWorks. It started from the concept design. After that, we design that extension in 2D and convert to the 3D. Is the component is usable, will proceed to the assembly of all the part. After that, if the assembly is success, we will do the 2D engineering drawing for prototype and this process is done. Um, the next method that I have for simulation, I using the SolidWorks simulation. Uh, the SolidWorks simulation is used to simulate the new design of extension. Um, the use of the simulation package provided by the SolidWorks for the simulation, which is the finite element method. This finite element method is a numerical method that divide a system into simpler and smaller part to define an approximate solution to a boundary value problem. This study focuses on stress and deformation. A static load is applied to ensure the new station that must withstand 1,400 Newton from any direction. So the start of the simulation is the loading and structure response to it is very slow in term of time. There is no vibration and material are isotropic. Next step is the simulation must in the 3D structure. After that, we must select the material for the new stanchion. After that, the meshing method and boundary condition are discussed in greater detail. After that, the boundary condition and external load are carefully applied. The result from this study is expected to propose a new design of extension by using SolidWorks as a design tool. Also, this research will expected that the design of the new extension will be produced and simulated to show the improvement. And this result also expected to reduce the hazard and injury risk for passenger during the emergency event. For the conclusion, the existing station on board the LRT Kelana Jaya Line is potentially a risk for the passenger during the emergency situation based on the train collision that happened at 24 May 2021. The station on board the train give the impact on the passenger, and the new design of the station can be reduced this risk and the impact of the collision on the passenger. So this is the reference for this research. I take from the online newspaper, from the conference, from the Ministry of Transport. I take from the journal, and also I take the reference from the internet source, such as from Alstom and Prasarana Malaysia Berhad. So this all for me. Thank you.